at this counting problem, a circular necklace is composed of n distinct beans. So we can think that we have n distinct beans here, 1, 2, 3, 4, and so on, right? So let's say we have n distinct beans. Each bean is to be colored in one of the four colors: red, green, yellow, or blue. So there are four choices for each beans here. But there's a requirement that there's no two adjacent beans are the same color. Hence, if let's say the first bean here is colored as the red, then the second bean can only be chosen from the remaining three colors except the red. Similarly, if the second bean choose a particular color, let's say blue, then the third bean cannot be colored as blue, but can choose from the remaining three colors out of 4. So now we let Sn to be the number of ways to color the necklace. Find out a recurrence relation for Sk in terms of Sk minus 1 and Sk minus 2 for each individual k greater or equal to 4. If you want to try to solve it by your own, you can just pause the video and try to solve by your own. And then you can refer to the solution that I'm going to present and to see whether you can solve it independently. Okay, now let's look at the solution. So the solution actually is quite simple and straightforward. We can label the necklace with k beans from 1 to k greater or equal to 4, and consider first 3 beans. There are 2 cases. So you can imagine this is k bean cases, Sk. So basically we want to color this particular k beans here. And I have already labeled the first bean, the second bean, and the third bean. So now there are 2 scenarios that we can consider. The first scenario is that the first bean and the third bean are the same color. So basically we have 4 choices for the first bean and for the third bean. Let's assume we color red for the first bean and third bean. Then there are remaining 3 choices for the second bean. Besides red, all the colors are available for the second bean. Let's say the second bean are colored as yellow. Okay. So for each choices, for example, for this particular choices, we color the first and third as red, and then color the second bean as yellow. Basically, if you see, because this color and this color are the same, we can hypothetically or imagine that we can actually merge these 2 beans together. And then you will find out actually it's similar problem to Sk minus 2. So if let's say we merge the 2 odd red color bean, the 1 and third together, and then remaining we still have the remaining beans. Basically it's k minus 3 beans plus r. So in total, for this particular case, we will become Sk minus 2, because we remove the second bean and combine the combine the first bean and third bean. And since that for first bean and second bean here, in total we have 4 choices. We can, so long as the color are the same, we can color in the similar manner. We can color them as both blue, both yellow, or both green. Hence, similarly here, it can be yellow, green, blue, or red. Hence, if we think in this particular manner, actually it reduces the problem into Sk minus 2. And since that for this particular second bean, we have 3 choices so long as it is not the same as the first and the third bean. So for example, in this particular scenario, because the first bean and the third bean are colored as red, so the second bean can be colored as either green, yellow, or blue. Hence, in total, we have 3 scenarios in this particular manner based on the color that we choose for the second bean. And for each scenario, we can reduce these particular problems into a Sk minus 2. Because so long as the first bean and third bean are the same, we can combine them together. We can combine them together by removing the second bean. Hence, in total for this particular case, we have 3 times Sk minus 2. 3 represent the 3 possible color of a second bean, so long as it's not the same as the first and third bean. And Sk minus 2 is just to think for each particular scenario, since the first and third bean are the same color, hence we can combine these 2 together. So this is the first case. So similarly for the second case, if we color the first bean and the third bean a different color, let's we assume that we color in this manner. if let's say the first bin is red, and then we color the third bin as blue. And in this particular cases, we only have two choices because the second bin cannot be red and blue, can only be yellow and green. And if we think in this manner, because the requirement, because the way that we label is that we always ensure that these two bins have different colors, hence we can just hypothetically imagine that this is the same case as k-1. Basically the same story. We remove the second bin, and then because the first bin and third bin actually are different colors, so we can safely put it side by side, and then also, and ensure that it meet the requirements of no two adjacent bins are the same color. Hence, for the remaining bins, we only have, so in total we have sk-1 because we remove the second bin. So we convert this problem into sk-1. Since we have two choices for the second bin, and for each choice of second bin, we reduce the problem in sk-1, hence in total is 2 times sk-1. By combining these two cases together, then we can reach the final conclusion. Sk is equal to 2 times sk-1 plus 3 times sk-2. Okay. That is the solution for this particular question.